to take notes like this.
Alright, so we're going to talk about the last rule of derivatives. It's called the chain rule.
Oh.
So a couple of weeks ago I gave you one that said we hadn't talked about what happens when there's an exponent with parentheses. We're going to talk about that today. Essentially what it is when you have a quantity or a whole group raised to an exponent, it actually creates two separate functions. The outside function is just the exponent, and then the inside function. So it's created two different functions because we have the exponent of 5, which if you wanted to get rid of the exponent of 5, you could always take that to thing times itself 5 times. But that's a lot of FOILing that you don't really want to do. So we treat it as two functions. So like I said, the outside function really is just this exponent, and then we have the inside function. So it creates something called the chain rule because what we do is we just take the derivative of each individual function and multiply it together, okay? So that's what this rule is showing. So it's, notice that the g of x is inside the f of x, so it's one function inside the other, and usually, for now, we're going to raise it to different exponents. So when you see that, what we do is take the derivative of the outside, which is just the exponent, so we're going to take the derivative of that using the power rule, but notice inside of it, this stuff will stay the same. Then we take it times the derivative of the inside. So you have to do the derivative in parts. So it creates kind of a chain of derivatives.
How long does this take? Did y'all see Vivian on the news this morning?
No.
She was on the news.
What for?
Wrestling.
Alright,
She looked pretty cool.
so like I said, we don't really pay attention to taking the derivative of the inside just yet. So the outside function is just the exponent. So if we had the exponent of 5 and we took the derivative of it, we would take the 5, we'd move it out in front, and then we'd subtract 1 from the exponent. We're still going to do that. We're going to put the 5 out in front. The inside stuff does not change. It stays the same.
Wait, where'd you get the 5 again?
The exponent. Yep. So the exponent moves out in front just like any other time we use an exponent. Every once in a while there might be a number out in front of the parentheses. If that ever happens, just take it times that number that's in front. Here it's just a 5. Like I said, if there's like a 2 out there, you would take the 5 times the 2, make that 10. Okay? That hasn't happened a lot, but that's one thing to watch out for. So that's the first part of the chain rule. And then the second part of the chain rule is we're going to multiply. Now we're going to focus on just the inside function and take its derivative. So what's the derivative of x to the 4th?
4x to the 3rd.
Yep. And the derivative of 3x?
3.
Yep, and then we'll do plus 3. I put a dot, but I'm going to switch it to a parenthesis to show that multiplication.
That's it?
And there's a chain rule.
Give me a second.
We don't have to multiply anything?
Now, one thing, I always say there actually is a couple things we could simplify, and I'll talk about that here in a second, but I would rather you leave it unsimplified and just not simplify wrong. Because with the chain rule, it makes it a little bit more challenging to actually simplify because we have two parentheses. We actually can't multiply these together. Any guesses why?
They are to the same
Exponent. Yep, so they're not to the same exponent, so we can't multiply them together. So we have to leave those separate. The only thing you could potentially multiply is since we have this 5, we couldn't distribute it into this exponent or into this parenthesis because of the exponent, but you could take 5 times both of these. Okay?
Couldn't you just keep doing the derivative until you didn't have an exponent?
You don't have to.
But could you?
You could. Yep. But if you were to do a second derivative of this, it's actually not a product or multiplication. So it makes it. So, like I said, if you leave it like this, it's fine. A lot of times, what I end up doing is, if you do try to simplify a little bit and you simplify it correctly, I might give you some bonus points. Okay. So that's why I always talk about the simplifying. But as long as you can get me to this point, that's fine. Like I said, the only thing we could simplify is this 5 could be multiplied to those two things because this parenthesis does not have an exponent, but we can't multiply anything with this stuff because the exponent of 4 on that quantity. Okay? So I could make it 20x to the 3rd plus 15 and then times x to the 4th plus 3x like I said, try to simplify if you want to, but like I said, as long as you have the chain rule right, usually what I end up doing is saying, I'll give you some.
Wouldn't it
extra
be
credit.
15x?
No, because we're multiplying it to this thing over here.
Is that supposed to be a minus in front of the parenthesis or no?
Oh, it's a times.
Okay.
I put a dot when I switched it to a parenthesis.
Oh, gotcha. Okay. I wrote a minus and then I was like, oh wait, it didn't go down. So I just want to make sure.
So that's the basic chain rule. So the derivative of the outside function was the outside function is just an exponent. So we move the 5 in front. The inside stuff does not change. Then subtract 1 from the exponent, so it became 4. Then we take it times the derivative of the inside. That's the basics of the chain rule. So it's here. Okay, so far when we worked with square roots or different things like that, it's just been the square root of x. The reason why we haven't done anything else underneath the square root is because when you have more than just x under the square root, it actually creates a chain rule. So the first thing before I do the derivative, I'm going to switch out the square root for its exponent. What's the square root? What's the exponent that goes along with the square root? 1/2. Yep. So really what I can do is rewrite this to 100 plus 5x to the 1/2 power. Okay? But since it was all underneath the square root, all of it gets the 1/2 power. And so now there's multiple things with an exponent on the outside, so that it creates a chain rule. So again, the first thing we focus on is the outside function, which is just the exponent. So we're going to take the derivative of that. So what do we do with the 1/2?
Put it in front.
Goes in front. The inside stuff does not change. So it's still 100 plus 5x. But now we're going to change its exponent, so we subtract 1 from it.
-1.
Yep. So there's the first part of my chain. Okay? Second part of my chain, take it times the derivative of the inside. So we just look at this now.
So it
Yep.
should be 5.
And like I said, if you leave it like that, it's fine. But you could, again, the things that don't have exponents, you could actually multiply those together. So you could simplify it to look like this.
Do you want us to simplify?
I like to try.
So if I try and like 2 and don't try and like 18, that's okay?
Yeah.
Alright. What if I have
So try to simplify. As long as you have the right first part, then I'll give you the points. Can you
Okay.
simplify correctly? I might give you some
What if we
What if I simplify wrong?
incorrectly?
Yeah, if I simplify wrong,
But I have the first part right.
If you have the first part right, you'll be fine.
Okay, good deal.
Okay. I encourage you to simplify. Like I said, sometimes, like, these first couple chain rules we do aren't too bad to simplify. Eventually, we're going to do some chain rules that are a little tricky.
Yeah.
Not even in this section, not so much. When we start pulling in other functions, that's when it can get a little tricky.
Is this year just gonna get super hard by the end?
Lovely.
I don't think so. Well,
Okay,
this is
good.
the last basic rule of derivatives, and then we start pulling in other functions. Like, we'll do some stuff with, like, trig stuff, we'll do stuff with log stuff, we'll pull in that. So.
No.
Okay. So the last two examples we're going to go through. So that's the basic chain rule. We can actually pair the chain rule with some of our other rules. Okay. So this one, notice there's x's both outside of the square root and inside of the square root. So everyone see that there's x's in 2 spots. Okay. If you see x's in 2 spots, okay, if there's an addition or subtraction in between it, we would just do the power rule. Okay, pair with the chain rule. With this one, when you see an x cubed in front of the square root, what operation is in between that?
Multiplication.
Multiplication. Okay. So if we're taking an x times another x, what that creates is a product rule.
Product.
So this ultimately is a product rule, but when we get to the derivative of the second part, we will have to use a chain. Okay. So this is ultimately product rule. So remember, the product rule is the derivative of the first times the second as is, plus the derivative of the second times the first So we have our 4 parts for our product rule, but within the product rule, we will have to do the chain rule. So first of all, I'm going to do this. So I'm going to make it x cubed times 4x plus 1 to the 1/2 power. So this is my first function. This is my second function. So to do the product rule, like I said, there's 4 parts. First part of the product rule is derivative of the first function. So we just look at the first function, which that's just x cubed. What's the derivative of x cubed?
3x squared.
3x squared. We took the derivative of the first. Then we take it times the second as is. Do not change anything about it. Okay. Then we do our big plus sign. So now when we get to the derivative of the second, that's when our chain rule is going to come into play. Because now we have something raised to an exponent where there's multiple things inside the parenthesis. So the derivative of the second is going to be a chain. So to do the derivative of this part, again, now we're focused on the outside function. What's going to happen to my 1/2? Yep. And then the inside does not change. Then what's my new exponent? Okay. Then to finish the derivative, we have to take it times the derivative of the inside. 4. Okay. Then here's one thing that the most commonly gets forgotten. Now we have to finish the product rule. Okay. So it's the derivative of the first times the second as is. This whole thing is the derivative of the second. Then we have to take it times
What?
the first.
Nice.
Okay. Maybe.
Can I just-
So this the 4 parts of the product rule. Derivative of the first times the second as is. This whole thing is the derivative of the second times the first as is.
Do you think I'm gonna remember that?
I'm not.
Alright.
My head hurts.
Locked and loaded, man.
Usually the one that understands.
She doesn't.
Yes, I do.
Alright,
then
I
explain
understand
it.
the chain rule. Not the
Yeah, that's what I thought.
I'm gonna simplify a little bit. This first part, there is actually nothing you can do to simplify. Because we have the 3x, that's as simplified as it gets. We can't distribute it into this because it has the exponent of 1/2. What we could simplify over here is all these things that are outside of the parenthesis with the exponent, we can multiply those together. Okay. So we take 1/2 times 4 times x cubed. So what's 1/2 times 4? 2 times x cubed. Yep.
What? Okay. Like really.
Okay, so that's the simplified version.
That's not like awful, but I don't think I'm gonna remember how to do it.
That's it. We're done.
Okay.
Yeah.
No more. Stop.
We got one more example.
Okay.
That's
Alright,
okay.
so that was a product rule. So again, this helping the underlining it helped kind of section off the different parts.
Yeah.
So I said we have 4 parts of the product rule. Derivative of the first times the second as is. That's the first 2 parts. And it's the derivative of the second times the first as is.
Okay, wait. Can you repeat that again?
So derivative of the first,
Derivative of the first. Derivative of first.
which is this.
Derivative. Okay.
This is first. This is second. Okay. So the derivative of the first times
Okay.
the second as is. Plus the derivative of the second, which is a chain rule, times the first as is.
Derivative of second. And then what's the last one?
First as is.
First. As is. Okay. Derivative first times second as is plus derivative second times first as is. Mike,
So we're gonna do one more.
Do you see my TikTok?
Yeah. And you have a grace and
We really exposed ourselves.
Because you guys are recording on YouTube.
what?
I'm recording right now.
Oh.
For
Hi,
Michaela?
Michaela, go like my TikTok. She been on?
No, it's a recording.
I'm
you
just-
stupid.
Alright, this
Make
one.
her get it.
So there's no product rule, okay, because all the x's are concentrated inside of the parentheses. But notice inside the parentheses we also have square root. Okay? So this one is a chain rule, ultimately. Roll with a chain. outside parenthesis with the 4, but inside that parenthesis we also have a square root. So this is a chain with a chain or a double chain.
Oh,
I'm gonna say, I'm gonna do whatever I want. And you're just gonna say it's fine.
So I'm going to go ahead and rewrite that inside part
And then
with the square root with 1/2 power. Ready?
Let me look.
Yep.
No.
So again, I don't have to worry about a product rule. If I had an x outside of this parenthesis with the 4, then I'd have to do a product rule. Okay, this one, I'm going to start again with the very outside function, which is just that exponent of 4. So what am I going to do with the 4? Yep, put it out in front. Do not change anything inside here. And then what's my new exponent? 3. So there's the first part of my chain rule. Second part, we're going to take it times the derivative of the inside. Okay? When we get to this part, how do we take the derivative of something where there's multiple things raised to an exponent?
Put the 1/2 in front.
We do another chain rule. So the 1/2 is going to go in front of it. The inside stuff does not change. And what's its new exponent going to be?
-1/2.
-1/2. Okay. Then we take it times the derivative of its inside, which is what's the derivative of this? 2x. Yep.
Wait.
I can't. What?
How'd you get 2x?
Yep.
Hold up here.
Because
That
the
wasn't
x
paid
squared
attention
is
at all.
the derivative of the. Okay. Okay.
Fancy.
Me neither.
Alright, so we started with the 4, right?
Mhm.
So the 4 moved out in front, the inside stuff did not change, the new exponent was 3. Then we moved to the inside derivative, which had another chain rule. So we followed that same pattern. So the 1/2 came, we haven't done anything with that yet. Sorry. So the 1/2, we're not quite done, but we'll finish in a second. So we have 1/2 moves out in front, the inside stuff again didn't change.
What happened to the
The new negative
single
1/2 here. But then we have to finish the chain rule here on the inside because we have to take the derivative of the very inside part. So that's where the 2x comes from. Everyone get where that came from? So then we also have to take the derivative of this, which that's not a chain rule.
That's just 6x.
Yeah, so just behind this I'm going to put 6x.
But
To the 4.
still, no. Like no.
Okay.
Oh, wait.
Yeah.
Okay?
What about the 4?
So the 4 moved out in front, inside stuff did not change, it's now to the 3rd power. Then we're done with the 4. Then we move to inside. When we do this part, it's another chain rule. 1/2 moved out in front, inside stuff didn't change, new exponent -1/2. But then we have to take it times the derivative of the inside part. Does that make sense?
Inside? Well.
Okay. And then we also have this little piece here that we have to take.
Derivative of first. Wait, are we? Is that the same?
It's not.
No. It's different.
Perfect. 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 We have a little.
Is that it? We're done?
Oh.
Okay.
The one little thing you can do to simplify,
No.
I'm actually not even going to rewrite it. The one thing I would do to simplify is this 1/2. I would take kind of the 2x. Okay. So I'd make that
Wouldn't you take it
x.
minus the 6x then?
Because this is a subtraction. It's not being multiplied. It's just
Yeah, but then that'll be an
6x.
x.
Yeah, but then you can take the 4. But this x would be attached to this thing. See, that's why I said sometimes simplification gets a little tricky. So if you try to simplify and you don't quite get it right, then I'm.
Alright.
Nope. Not doing that.
Questions? Okay, it's been a while, but we have books in.
No.
No.
Who has the book?
I do.
Mine's in my car.
I was gonna say Zai probably has his. Look at that.
Really,
How
you
do I
want to take
know?
a picture of Zara's book and put it in the group chat?
No, I sure will. Anytime.
Okay,
We share around here. Is it this page?
so page 165.
Haley, are you working for me tonight, though?
I don't know. My hours aren't showing up.
Well,
and a B. I only want you to do the A. Okay? So that's why it says 5A through 10A. Again, if all the X's or T's or whatever variable they use is concentrated inside the parentheses, it's just chain rule. If there's a X in two different spots, so there's X's inside the parentheses and X's outside the parentheses, that creates a chain rule. Or a chain and a product rule. 9 and 10 are actually just quotient rules. There's no chain anything about it. So there's just a couple chain rule or quotient rules thrown in there. That you don't have to use the chain rule. So there's a couple of them you don't have to use the chain rule. 15A as a double chain, kind of like that last example we just did. So we'll do a double chain with that one. And then 22 and 24, you do not actually have to solve it out, okay? You just have to tell me the rules and the order that you would do it, because it is a super long equation and you don't want to actually do the derivative. So 24, you don't have to solve it out. You just tell me the rules that you would use to solve it out. Does that make sense?
Wait, is that for 24?
24,
Okay.
yep. On 22, ignore the directions and just find the derivative using the chain rule. And then don't even worry about plugging in that number that's next to it. So 22, just find the derivative.
That is easy.
Yeah.
Unless I'm thinking it's 2.
Okay? It's 24. Just tell me the rules that you would use. And try to do it in the correct order. It's like on the example 3, technically we started with the product rule, then we used the chain rule. And then it's 29. 29 and 30 is finding velocity. Which velocity? I didn't do an example of that. What derivative is the velocity? First. Okay, so just find the first derivative and then plug in the number.
I don't know what I'm doing, so. So we gotta do all